Hello everyone, my name is Nidamarthi. So this is my second MongoDB aggregation framework screencast for the genealogist consultation project. So in this project, the database stores the collection sessions provided by the genealogist to the clients and who are seeking the family history advice and the research support. And also each consultation includes the details such as in consultation year, consultation mode, which is of the type array, and the topic which is of the type array, and remaining or normal fields. So, and here it also stores the two embedded documents. One is genealogist and one is client. And we can see different types of columns in each embedded document. So in the first screencast, I demonstrated an aggregation that focused on the array field using unwind. So in this screencast, I will focus on the different type of aggregation, embedded document fields, conditional classification, and the compound grouping. So this is about this detail. Now to import the data into the JSON, first we have to import the create the data. So the data was created using these field names, and then it was converted into a consistent format to make it ready to the import for the MongoDB. So let me show you how I can prepare the data and to import into the MongoDB. So this is my final JSON file which have created up to the 1000 documents using the field names which I have shown earlier. So I have created ID, consultation year, duration, hourly rate, other costs, payment status, report delivery, DNA use, consultation mode, topic, record type used, and there is embedded document which is genealogist, which includes the name, gender, year of the birth, base country, employment type, years of experience, and the preferable project duration, and the contact method, and the specialization. And also the second embedded document which is the client, which includes name, country, and the type. So in this we can clearly see the different types of suppose the client which is stored in the form of an array here. So here we can clearly say it was opened with the curly braces, and then finally both two arrays were closed with two curly braces. So we can clearly say that the JSON format should be work as an embedded array. It should be in the embedded format before going to import into the MongoDB. So I am now currently open the command prompt, and then I ran the file path. So let me explain this. So here I first install the MongoDB tools, and then I gave the path here using cd, and then I used the Mongo import function, and this is the file path of my JSON, followed by the database name and the collection name, which is consultation, which is of the type array. So we can clearly say that the 1000 documents were imported successfully and 0 documents failed to import. So that means it is ready for the analysis. So I now open the Mongo shell to run the queries. So first of all, I now import, I need to switch to my data set. So how we can switch is use and the collection consultation DB. So we clearly switch to our database. Now let me verify the collection by running show collections. So it should show only one collection. So it is showing the consultation, that is our exact database which we are working on. So now let me check the count of the consultation documents. So db dot consultation dot count documents. So see clearly, we can clearly see that the 1000 documents which are imported successfully earlier is showing correctly here in the MongoDB. That means all the 1000 documents are imported successfully. Now here the data set is ready for the aggregation analysis. So let me run the aggregation query, another aggregation query to check whether the results are producing accurate or not. So if you want to clear the screen, you can use CLS. Now I am working on the another aggregation query, which is question 11. So here the aim is to group the consultations by the genealogist, employment type and experience level. And I will classify the genealogist into junior, experienced and senior. Then I will calculate the total consultations, average income and then the total income for the each group. So this is one of the very strong aggregation example because it uses the embedded document fields such as the switch and the calculated income, compound grouping such as sum, average, round and the sort. So let me explain this question by breaking down into the stages. So here the first stage I used is project. This stage extracts the values from the embedded genealogist document and I extract the employment type and rename it as employment type and also extract the genealogist dot years of experience. So this stage also creates the estimated income here because the estimated income is calculated by the duration into hourly rate by adding other cost. So the most important part of this stage is switch. Here switch is used to create a new field called experience band. If the genealogist has 15 or more years of experience, they are classified as senior. And if they have 5 or more years of experience, then they are classified as experienced. So otherwise they are classified as junior. So this converts a raw numeric field years of experience into a meaningful analytical category. So let me run this stage 1. So we can clearly see that it printed all the values here because we are just looking for the employment type, years of the experience and the estimated income experience band. These two are calculated fields and these three are we are looking for. So if you want more to see this, we have to type it for more. Then you can see the more records. So in the second stage, I used the group because this is one of the main summary stage here. The ID contains two fields, that is employment type and the experience band here. So this is called compound grouping because the data is grouped by more than one field and this gives a more detailed result than simply grouping by employment type alone. For example, it allows me to compare full-time senior genealogist, part-time experienced genealogist and other combinations. So inside the group, total consultations uses this sum to 1 to count the number of consultations in each group, and average of duration is uses average to calculate the average consultation duration, and the average income uses average function to calculate the average estimated income, and the total income uses the sum function to calculate the total estimated income for each employment and experience group. So at this stage, the output here I will show you. Let me run the output here. So at this stage, the output changes from individual consultation records into the grouped. Here see analytical summaries. see which is of the group type, we can clearly see that in the ID we can see employment type and the experience band and the total number of consultations and the average of the duration, average of the income and the total of the income. So let me go to the stage 3 then. Here the third stage is another project. Because after grouping the employment type and experience band are inside the ID object, right? So this projection moves them out into the separate normal fields called employment type and the experience band. So let me run this output and I will show you. See clearly. So they came out of that ID. So this is how it works. And also I removed the ID by setting ID to 0 here. Because the final output is easier to read without the nested group identifier, and the round operator which is used here is to round the average duration, average income and then income of the two decimal places. So this improves the readability and makes the output cleaner for the final report. So here the final stage is sort. I sort by the employment type and the experience band in the ascending order. So this organizes the output so it is easier to compare the employment and experience categories. So let me run this output so that we can clearly see here. So it shows the total consultations, average duration, employment type, experience band and the total income. So here, to change the impact of changing one stage, I changed the final sort here. So previously, we can see the the results were sorted alphabetically, right? And by the experience band. Now I sorted here by the total income. So let me run this out query. So we can clearly see it was sorted by the total income in descending order. So this changes the analytical focus of the output because the earlier version was easier for category comparison. But this version is better for identifying which employment and experience group generated the highest income. So this demonstrates how changing one stage in the aggregation pipeline can change the interpretation of result. So to conclude, this aggregation demonstrates the important MongoDB aggregation framework features. It uses embedded fields from genealogist document, calculated income using the multiply and add condition and using add, and also the conditional classification using switch, and the grouping by using the compound which is ID, and the summary calculations using the sum and average, and the output cleaning using round and sorting using sort. So this screencast is different from the first aggregation screencast because the first focused on array processing using unwind. But while this one focuses on embedded documents, conditional classification and compound grouping. Together, both examples demonstrate a strong range of aggregation framework and shows how MongoDB can be used for the practical data analysis.